This is Module 4, Lesson 25, Solving System of Linear Equations Without Common Coefficients Using Elimination. Now, we've talked about elimination before. We did that in our last lesson, Lesson 24, and I worked several problems for you. Now, we're going to do it when we don't have common coefficients. Now, our objective is to find the solution for a system of two linear equations without common coefficients using elimination. You're going to find this in Eureka Module 4 Workbook Lesson 28 and in our Module 4 packet, the pages 22 through 25. Now let's review real quick. When we're trying to find the solution for a system of linear equations, what we're talking about when we're talking about a system of linear equations is we're talking about two equations. Okay, in our case, we're going to be talking about two equations. Hold on, let's get some pens that we like. Now, this could be a system of linear equations here, like 2x plus 3y is equal to 6. And y is equal to 2x plus 5. That could be a system of linear equations. See, it's two equations, all right? Forms a system, see the brackets. If you're talking about a system of linear equations, what we're asking is where do the two lines intersect? Your solution will be the xy coordinate for where the two lines cross. Now, this one has one solution because it's got one place where it crosses. This is a set of parallel lines, okay? It has no solution. All right, and if you have two lines that are right on top of each other, what you now have is a set of lines that has infinitely many solutions, okay? And with infinitely many solutions, that means this is two equations that are exactly the same, okay? Now, there's ways to find the solution, ways to find the solution of a system of equations. One is to graph the two lines. If you graph the two lines, you could read it off the chart, your xy value. Okay, we did that earlier. Second way to do it is substitution. That's when we plug in an expression for one of the variables. For instance, if you've got y is equal to 2x plus 1, and you've got x plus y equals 8, then I could plug this 2x plus 1 in for the y, right? That would be substitution. Find your x, then plug it into one of the equations to get your y. And then the other way, and we talked about this in our last lesson, is elimination. Okay, elimination. That's where we get rid of one of the variables. Now, let's look at elimination. We did some elimination on our last lesson. Go back to one of them just real quick. On our last lesson, we did some elimination. It was things like this. Well, sorry. It was things like this. Elimination. It was things like this where we were getting rid of one of the variables, okay? If you have two equations like this, and neither one of them says x is equal to or y is equal to, then you can't use substitution, you can use elimination. Remember, when you were doing elimination, what you did is that you went ahead and you tried to see what you needed to do to get rid of one of the variables. In this case, these are exactly alike, so what you're going to wind up with is an infinite number of solutions because that's the same equation. But in this case, if you're adding these two together, remember you needed to get rid of one of these. Since you got negative 8x and negative 8x, you'd multiply everything times negative 1. You'd have negative 8x plus y is equal to 6. And you would have, remember this is just changing the sign in front of each one of them, 8x minus 3y equals 14, okay? 8x plus negative 8x is gone, that's gone. you've got a 1y plus negative 3y is negative 2y is equal to 20. You divided both sides by negative 2, and your y was equal to negative 10. To find your x, you'd plug this in. To see you've got your y. Okay, we need to find the x. You plug it into either one of these. You'd substitute. Negative 8x plus y is equal to 6. Okay, that would be negative 8x, and plug in our y, plus negative 10 equals 6. Negative 8x, so we cross the equal sign here, negative 8x, and you got a plus negative. Okay, so that's the same thing as saying minus 10 equals 6. I'd add 10 to both sides. Negative 8x would be 16. I'd divide both sides by negative 8. And x would give me negative 2. So our point is negative 2, negative 10. Okay? Now, let's go back down here and let's look at what we're doing when we don't have the same coordinates. In that case, in this case here, guys, both of these were negative 8. The coefficients were the same, so I only needed to use a negative 1. What if our coefficients are not the same? Now let's look at one of these. And here we've got one. I don't have x is equal to. Okay. I don't have y is equal to. Okay. So I can't use substitution. I have to use elimination. I need to eliminate one of these variables. Well, now let's look at these. In this case, if there's nothing here, doesn't that mean there's an understood 1? 1x and 4x, okay? I can't just multiply one of those by negative 1 and get rid of it. I have a negative 3 here and a 7. Not an easy way to get rid of one of those. And see, our numbers are on top of each other. We're going to have to use elimination, but I can't just multiply something by negative 1 to get rid of it. Let's look at these two coefficients. I've got 1 and I've got 4. Is there anything I can multiply one of these by such that if I added them together, I would get 0? You see, this is 1x, that's 4x. What if I multiplied this by negative 4? Wouldn't that give me negative 4x plus 4x? Negative 4x plus 4x is equal to 0. Okay? So see, this would work. Let's do that. Everything up here, let's multiply by negative 4. Okay, now we're not just changing the signs. We are using our distributive property on everything up here. This equation becomes negative 4 times 1 is negative 4x. Negative 4 times negative 3 is positive 12. Why? Negative 4 times 2 is negative 8. Okay, now we're adding this bottom equation here, plus 4x plus 7y equals 27. All right. Negative 4x plus 4x. This is gone because that gives me 0. 12y plus 7y is 19y. Okay. Negative 8 plus 27 is 19. So if 19y is equal to 19, all I need to do is divide both sides by 19. Y is equal to 1. Our y is 1. We need to find x, don't we? You can plug it into either one of these equations. It does not matter which one. Okay? I'll plug it into the top one because I've got y. I'm looking for x. X minus 3y equals 2. Let's plug in the y. X minus 3 times 1 equals 2. Negative 3 times 1 is negative 3. Okay, to get to x, let's add 3 to both sides. X is equal to 5. So our coordinates are 5, 1. Okay? Let's try this one, okay? Does anything say x is equal to or y is equal to? It doesn't, does it? So I can't use substitution. My x's are lined up, my y's are lined up, my equal signs are lined up, my numbers are lined up. I need to use elimination. That means I'm adding the two equations. But I need to get rid of one of the equations. Let's look at our coefficients. Here we have 7 and 1. Here we have negative 2 and negative 5. What would be easier to multiply one thing by and get rid of everything? Well, there's not much I can do with the 2 and 5 unless I multiply this by 2 and that by this by 5 and that by 2. But what if down here I multiplied everything on the bottom by negative 7? Okay. If I do that, I have 7x minus 2y equals negative 32. Negative 7 times 1x, see, we're adding these, let's don't forget. Negative 7 times 1x is negative 7x. Negative 7 times negative 5 is positive 35. Negative 7 times negative 47, okay? Grab your calculator. You've got a calculator to use for this. And that would give you 329, okay? Now, 7x plus negative 7x is 0. This is gone. Negative 2 plus 35 gives me 33y is equal to, and 329 basically minus 32 gives you 297. Okay. Now, to solve for y, I need to divide both sides by 33. And I get that y is equal to 9. Big numbers, but I came out with a pretty simple coordinate. My y value is 9. We need to find our x value, don't we? Okay. So let's find our x value. It doesn't matter which one of these we choose. I'm going to choose 7x minus 2y equals negative 32. I'm going to put in my y. 7x minus 2 times 9 equals negative 32. 7x minus 18 equals negative 32. Let's add 18 to both sides. 7x is equal to 32, negative 32 plus 18 is negative 14. You put that in your calculator. And if I divide both sides by 7, x would give me negative 2. My coordinates are negative 2, 9. That's where these two lines intersect, okay? Now let's try number 3 here. If we're trying to find the solution, we're trying to find where the two lines intersect, right? The first question we ask ourselves, is it x is equal to or y is equal to? No, so I can't use substitution. My x's are over each other. My y's are lined up. My numbers are lined up. I'm going to have to use elimination. That means we're adding these two equations. But we've got to figure out a way to get rid of one of these variables. We've got to figure out a way to eliminate one of them. 5 and 3. Not much I can multiply those by to make that work. Can't do just one number, can I? What if I multiply this 2 up here by a -2? Wouldn't that give me a -4? Wouldn't that get rid of the x? Wouldn't that eliminate it? So let's multiply everything up here by -2. -2 times 2x is -4x. -2 times -5 is positive 10y. -2 times 39, use your calculator, 39 times 2. That would give me a -78. Okay. And we're adding these. Let's don't forget that. I've got 4x minus 3y equals 43. -4x plus 4x gives you 0, right? 10y plus -3y gives you 7y. -78 plus 43 is -35. Okay, now let's divide both sides by what? By 7. And y is equal to -5. All right? Now we've got our y. Let's go after our x. Doesn't matter which one of these we use. 2x minus 5y equals 39. So we're just substituting this y in so we can get the x value. 2x minus 5 times -5 equals 39. 2x plus 25 equals 39. Let's subtract 25 from both sides. 2x is equal to 14. Divide both sides by 2. And x is equal to 7. We got 7, -5. This is the place that these two linear equations intersect. And then on number 4, let's look at this. Can we use substitution? Is there any x is equal to or y is equal to? No, there's not. Our x's are lined up, our y's are lined up, our equals are lined up, and our numbers are lined up. I'm going to use elimination. I'm going to eliminate one of the variables. I've got 4 and 3 as my coefficients here. There's nothing I can multiply just one of them by to get rid of it. This is an understood 1. I've got 1 and 2 here. Is there anything I can multiply one of these by to eliminate the variable? What if I multiply everything here by -2? Okay. I've got -8x minus 2y equals 32. Okay. I'm adding this. I've got 3x plus 2y is equal to -17. -8x plus 3x gives you -5x. -2y plus 2y gives you 0. That is equal to 32 plus -17. So find the difference between 32 and 17. That would give you 15. Let's divide both of these by -5 so we can get to the answer. And your x is equal to -3. Okay? Remember, we're looking for where the two lines intersect. The x is -3. Okay, let's find our y. Choose either one of these to substitute in. 4x plus y is equal to -16. Our x is -3, so let's substitute it in here for our x. 4 times -3 plus y equals negative 16. 4 times negative 3 is negative 12, plus y equals negative 16. Let's add 12 to either side. Y is equal to negative 4. Negative 3, negative 4. Okay, let's go to the next page and let's try these. I'm trying to find where these two lines intersect. Okay, is there any x equal to or y is equal to here? There's not. The x's are lined up, the y's are lined up, the numbers are lined up. I cannot use substitution. I'm going to have to eliminate one of the variables. Remember, that means you're going to be adding these two equations. I'll look at the coefficients and I see which one can I eliminate. What can I multiply one of these whole equations by to eliminate one of the variables? I have a negative 3 and a 2. I can't multiply the negative 3 by anything to get 2, nor the 2 by anything to get negative 3. But we know there's a 1 here. It's understood. Can't I multiply this 1 by negative 5? So I have a positive 5y plus a negative 5y. Let's multiply everything on the bottom by negative 5. Negative 3x plus 5y equals negative 24. Negative 5 times 2 is negative 10. Now remember, we're adding these. Negative 10x. Negative 5 times positive 1 is negative 5. Negative 5 times 16. If you multiply 16 times negative 5, you're going to get negative 80. Okay? So let's add everything. I have negative 3x plus negative 10x, negative 13x. 5y plus negative 5y, that means we have eliminated the y, because that would be 0, equals, and if you add these, you've got negative 104, right? Now I'm going to need to divide both sides by negative 13. I know these are awfully big numbers. Xn is equal to negative 104 divided by negative 13. A negative divided by a negative is a positive. So x is 8. Our x coordinate is 8. How do we find our y? We substitute it into either equation. Doesn't matter which one. I'm going to go to the bottom one simply because it looks easier. 2x plus y equals 16. If my x is 8, that's 2 times 8 plus y is equal to 16. 2 times 8 is 16. 16 plus y is equal to 16. Let's subtract 16 from either side, and y is equal to 0. Now, let's look at number 6. Let's try that one. Remember, do I have x is equal to or y is equal to? No, so I can't use substitution. I'm going to have to use elimination. I'm going to have to eliminate one of these variables. 2 and 7. Can I multiply either one of those by something? Can I multiply 2 by anything to get 7? No. Can I multiply 7 by anything to get 2? No. This is negative 3 and negative 1. Can I multiply negative 1 by anything to get negative 3? Yes, I can simply multiply it by 3. So let's multiply everything here by 3. We start out with 2x minus 3y is equal to negative 20. Okay, 3 times 7 is 21. Okay, so that's 21x. 3 times negative 1 is negative 3. Well, we don't need negative 3, do we? We need positive 3. So we need this to be a negative 3. So let's change that. Negative 3 times 7 would be a negative 21. Negative 3 times negative 1 is a positive 3, so it's positive 3y. Negative 3 times negative 13 would be a positive 39. Now, let's look to see what we've got. Negative 21 plus 2 would give me a negative 19x. Negative 3y plus positive 3y is 0, so this has been eliminated. We've eliminated the y. Negative 20 plus 39 gives me 19. Let's divide both sides by negative 19. X is equal to negative 1. Where does this intercept? It intersects at negative 1. Let's find the y. 2x minus 3y is equal to negative 20. My x is negative 1. 2 times negative 1 minus 3y equals negative 20. That is negative 2 minus 3y equals negative 20. Let's add 2 to both sides. Negative 3y is equal to negative 18. Divide both sides by negative 3. Y is equal to 6. Okay? So our coordinates of the point of intersection is negative 1, 6. That is our solution for this particular problem. Let's do 7. Okay, I'm trying to see if I use substitution or elimination. Does it say x is equal to or y is equal to? No, it doesn't. Our x's are lined up, our y's are lined up, we've got numbers lined up. We're going to have to use elimination. We need to find a way to eliminate one of these variables. Is there anything I can multiply 2 by to get 5 or 5 by to get 2? Not just a whole number. Not, it's going to be easy. Is there anything I can multiply 3 by to get 9? Yeah, you can do it by 3. How about that? And I need to do this by negative 3, so I have negative 9y plus 9y, right? That would allow me to eliminate that variable. That would give me a 0. So everything up here we multiply by negative 3. Negative 3 times 2x is negative 6x. Negative 3 times 3y is negative 9y. Negative 3 times 1 is negative 3. Okay, we're adding 5x plus 9y is equal to negative 2. Negative 6x plus 5x is negative 1x. Negative 3y plus 9y is, whoa, we didn't multiply this one, did we? Negative 3 times 2 is negative 6. Negative 3 times 3 is negative 9. Okay, we did that one. Negative 3 times 1. Okay, sorry about that, guys. Negative 6x plus 5x is negative 1x. Negative 9y plus 9y is 0. That eliminates that variable. Negative 3 plus negative 2 equals negative 5, right? Okay. So I need to divide both sides by negative 1, and x is equal to 5. If I'm looking where the two lines intersect, my x value is 5. Let's find our y. Okay. Doesn't matter which equation, 2x plus 3y equals 1. X. 2 times 5 plus 3y equals 1. 10 plus 3y equals 1. Minus 10, 3y is equal to negative 9. Divide both sides by 3, and y is equal to negative 3. Your x is 5, your y is negative 3. Okay, there's your answer, 5, negative 3. Okay, number 8. 2x minus 5y equals negative 28. 6x minus y equals negative 28. How can I get rid of either one of those variables? Okay, I know it doesn't say x is equal to and it doesn't say y is equal to, so I've got to use elimination. Well, if I look here, this is understood one here. Can I multiply this by -5, everything here by -5, and then I would get a positive 5y. -5y plus positive 5y would be just what you need. 2x minus 5y equals -28. -5 times 6 is -30x. -5 times -y is positive 5y. Remember, we're adding these, right? -5 times -28. Let's multiply -5 times -28. Okay? And I get -140. Or wait, I get positive 140 because a negative times a negative is a positive. Okay? -30 plus 2x would give me -28x. -5y plus 5y is 0. This one is eliminated. Now, -28 plus 140 gives you 112. All right, now we need to divide both sides by -28 to get down to our x. 4. Your x is equal to -4, okay? Now, let's plug this in. I've got 2x minus 5y is equal to -28. The x is -4. 2 times -4 minus 5 times y equals -28. Okay? 2 times -4 is -8 minus 5y equals -28. Okay? Let's add 8 to both sides. -5y equals -20. Divide both sides by -5, and y is equal to 4. Your coordinates where you intersect is -4, 4. Okay? Then let's look at number 9 here. If I'm doing this one, does any of it say x is equal to or y is equal to? It doesn't, does it? But I need to get rid of one of these variables. I know there's an understood one here. Can I multiply everything here by -2, and then I'd have 2x plus -2x, okay? I've got 2x plus 4y is equal to 9. -2 times 1 is -2x. -2 times 2y is -4y. -2 times 15 is -30, okay? 2x plus -2x gives you 0. Okay, 4y plus -4y gives you 0. 0 is equal to -21. Well, think about that, guys. If 0 is equal to -21, there's no x or y's here. There is no solution. No solution means we are talking about parallel lines. No, I know I can't draw worth a darn. These are supposed to be a rendition of parallel lines, okay? Think about this, guys. If you multiply everything by here by 2, I had 2x plus 4y equals 9. If you multiplied everything here by 2, you'd have 2x plus 4y equals, equals 30. These two are exactly the same, aren't they? 2x plus 4y can equal to 9 and 30 at the same time, so they're parallel lines, okay? All right, let's try a few of these. We may not do all of these, but we will do the evens on this, do some of the evens on this. 2x minus 7y is 9, x plus 2y is 10. Neither of these say x is equal to or y is equal to. I've got a 2x here. Can't I multiply everything here by -2? That gives me 2x minus 7y equals 9. That gives me plus -2x minus 4y equals -20. Okay? 2x plus -2x is 0. -7x plus -4x is -7, is -11y. 9 plus -20 is -11. Divide both sides by -11, and y is 1. Okay, so your y is 1. How do you find your x? Substitute it in. X plus 2y equals 10. x plus 2 times 1 equals 10. X plus 2 is equal to 10. Let's subtract 10 from both sides, 2 from both sides. X is equal to 8, okay? So your coordinates are 8, 1. That's where those two intersect. Let's look at number 4. Neither of these says x is equal to or y is equal to. I need to get rid of one of the variables. I need to eliminate it. You know, you're adding these. Have 3x here and a 1x here. So if I multiply by -3, everything by -3, I have 3x minus 4y equals 1. I'm adding -3x plus 21y equals 23 times -3, okay? Make sure you try that. Put it in a calculator so you make sure you don't make a mistake. Okay, you've got -69. 3x plus -3x, that's gone. -4y plus 21y. And if you simply find the difference between those two, you've got 17y is equal to 1 plus 69, -69, that's -68. Divide both sides by 17. And you get y is -4. Okay, how do you find the x? Plug it into either one. How about x minus 7 times -4 equals 23. X plus 28 is equal to 23. Okay, we subtract 28 from each side. X is equal to -5. So your coordinates are -5, -4. And number 6. Okay, if we look at this, how am I going to make this work? So why don't I multiply everything up here by, if this is a -2 and that's a -1, I need to multiply everything up here by -2, don't I? That would give me -10x, -2 times that would give me positive 2y is equal to -2 times 5 is -10. Here I'm adding 10x minus 2y equals 15. Okay. -10x plus 10x is 0. -2y plus -2y, positive 2y plus -2y is 0. -10 plus 15 is 5. You have no solution. Okay, now, guys, you could have looked at it this way. Let's just take it logically and look at it. If I'm looking at the equations that I'm dealing with here, I have got 5x minus y equals 5. I've got 10x minus 2y equals 15. If I multiplied everything up here by 2, let's look at that. You get 10x minus 2y is equal to 10. And here you've got 10x minus 2y equals 15. Is that possible? Can 10x minus 2y equal both 10 and 15? No, it cannot. So there is no solution, right? Okay. Let's look at the next page. We're going to do just the evens. Okay, if I'm looking at this one, there's no x is equal to, no y is equal to, hence we need to get rid of one of these. Okay, I'm going to suggest, since this is a positive 7y, and we're trying to eliminate a variable, let's multiply this by -7. So I wind up with -7y. Okay, -7 times -3 is 21x. -7 times this one here would be -7y. -7 times -8 is 56. Okay, positive 56. Now, we've got 2x plus 7y equals -10. 21x plus 2x is 23x. -7 plus positive 7 is 0. 56 plus -10 is 46. Okay, let's divide both sides by 23. and x is equal to, let's see, 46 divided by 23 is simply 2. Now, plug this into either one of those, it doesn't matter. Negative 3x plus y equals negative 8. Negative 3 and our x is 2 plus y equals negative 8. Negative 3 times 2 is negative 6 plus y is negative 8. Let's add 6 to both sides, and y is equal to negative 2. Our coordinates are 2, negative 2. Okay? Let's look at 10. Which one can we get rid of? Okay, we know this is an understood 1, so let's multiply this by a negative 3. If I do that, I would have positive 3 up here. 4x plus 3y equals, let's see, 123. 4 and 3 is 12, 3 and 1 is 3. Okay. Plus 2x minus 3y equals negative 33. Okay, there we go. 4x plus 2x is 6x. 3y plus negative 3y is 0. 123 plus negative 33, okay, is going to give you 90. Okay, let's divide both sides by 6. Let's see if we've got something wrong there. Hold on. 90 divided by 6 would give me 1.5. X is 1.5. How would you get to y? You'd plug it in right here. But we're going to stop right here at this point. Let's see, 2 times 1.5 minus 3y equals negative 33. That will give me 3 minus 3y equals negative 33. Let's add 3 to both sides. Negative 3y is equal to negative 30. Divide both sides by negative 3. And y is equal to 10. Your coordinates are 1.5, 10. Okay? Simple enough. All right, guys. That's the last one we're going to work on this. There's a couple of them in the workbook. If you want to try these, they're on page 357. In this case, you've got y is equal to, so you could use substitution. You could just simply plug that in. I would plug this in for the y. 4 times 3x plus 2 equals, and let's go back to here, 12 plus 12x. Distributive property, 12x plus 8 equals, and I'm going to just rearrange these, 12x plus 12. Look at that. Is there anything that would make that work? No, there's not. And in fact, I'm going to show you a little farther. Let's subtract 12x from both sides. 8 is equal to 12. There is no solution. If it says no solution, what we're talking about is a pair of parallel lines. Okay? Number 7. I'm trying to get rid of one of these variables. I can't do much with the 3 and the 4, but how about we take this right here and we multiply that by a positive 2. That gives me 4x minus 3y equals 16. Now I've got negative 4x, see we're adding these, plus 8y equals negative 4. 4x plus negative 4x gives you 0. Negative 3y plus 8y is 5y. 16 plus negative 4 is 12. Is that 5y? Did I miss one? 8y? Oh, that's it. Okay. That's it. Okay. So your y is going to be equal to, and they do a lot of fractions in this. I will tell you that. Y is equal to 12/5. Okay. And if you're going to find x, you just have to plug it in and go from there. Now, we're going to stop at this point because we've spent about 45 minutes working a lot of these different ones. I think we've worked enough of them. I'm going to stop at this point for you. If you have any questions, guys, go back and look at some of them that we've worked because we've worked a lot of them.